Good day, everyone. We are Group 10, and we'll be talking about our proposal inventory system for the food company Mondelez. So, table of contents. First is the introduction. Second is the problem statement. Third is the business rules. Fourth is the ERD together with its attributes, entities, and relationships. And last is the SQL. So, what is Mondelez? Mondelez International is a massive snack company that boasts an impressive global net revenue of approximately $36 billion as of 2023. They have achieved the coveted number one global position in the biscuits category, which includes cookies and crackers, and they hold the number two spot in the chocolate industry. Additionally, they are rapidly expanding their presence in the baked snacks market and demonstrating their commitment to providing a diverse range of delicious snacking options to consumers worldwide. This renowned organization has established its operations in over 80 countries across the globe. They take pride in their diverse and talented workforce, which comprises approximately 91,000 skilled employees engaged in various activities, including manufacturing, research, packing, development, distribution, and administrative work. So next is the problem statement. What is the objective of our inventory system? The objective of this project is to design an effective or efficient inventory management system for Mondelez, a leading global snacks company, especially for its operations in the Philippines. The system aims to streamline inventory tracking, improve stock control, and enhance overall efficiency in managing Mondelez's diverse range of products. So in details, it's for product management. It entails to capture detailed information about each product, including name, category, quantity, and expiration date, and also to assign unique identifiers to products for easy tracking. It's also to categorize products based on types. Example is snacks, chocolates, and brand. Next is the supplier management. It aims to record information about suppliers such as name, contact details, and products supplied. And it is also used to establish relationships between suppliers and products to facilitate procurement processes. So next is the for inventory tracking. So it should monitor stock levels in real time to prevent stockouts or overstocking, track incoming, outgoing inventory movements, including purchases, sales, or returns. It's also to implement FIFO or first in, first out, or other appropriate inventory valuation method to ensure accurate inventory costing. So last is for order management. It's to process purchase orders from suppliers and track their status until fulfillment, and generate sales orders from customers and manage order fulfillment processes, and handle returns and exchanges efficiently to maintain customer satisfaction.
So for our business rules, each customer contacts one salesperson, and each salesperson can be contacted by multiple customers. Each salesperson places multiple orders, and each order is placed by only one salesperson. Each order generates one or more order lists, and each order list corresponds to only one order. Each order list contains many products, and each product belongs to only one order list. Each product is stored in one warehouse, and each warehouse stores many products. Each warehouse employs one or more employees, and each employee works for only one warehouse. Each product belongs to one product type, and each product type includes many products. Each product is supplied by one supplier, and each supplier provides many products. Each return record corresponds to one or more orders, and each order can be returned by only one record. Each return report can be approved by only one quality check, and each quality check can approve one or more multiple return reports. Each warehouse returns products to one or more quality checks, and each quality check receives returned products from only one warehouse. Each supplier returns one or more damaged items, and each damaged item comes from one only supplier. Each damaged item can be checked by only one quality check, and each quality check can check one or more damaged items.
So for our SQL, for the entities, we have first the supplier table. It contains supplier ID, address, product ID, warehouse ID, and damage ID. For the product table, um, it contains product ID, which is the primary key, product name, product price, stock count, product type ID, and supplier ID. For the warehouse table, it contains the warehouse ID, which is the primary key, stock count, address, max capacity, minimum capacity, product ID, and supplier ID. For the employee table, it contains the employee ID, which is the primary key, employee name, contact number, and warehouse ID. For the customer table, it contains the customer ID, which is the primary key, customer name, contact number, and salesperson ID. For the orders table, it contains the order ID, which is the primary key, order date, total price, customer ID, and order status. For the salesperson table, it contains the salesperson ID, which is the primary key, sales name, customer ID, order ID, and warehouse ID. For the order list table, it contains the order list ID, which is the primary key, quantity, order list price, the payment, the order ID, and the product ID. For the returns table, it contains the return ID, which is the primary key, return date, return status, reason, order ID, and order status. For the damage items table, it contains the damage ID, which is the primary key, damage quantity, return ID, and order ID. For the quality check table, it contains the check ID, which is the primary key, past status, damage ID, warehouse ID, and supplier ID. And lastly, for the product type table, we have the product type ID, which is the primary key, and product type name.
So here is the relationships. Salesperson to customer. One salesperson can assist many customers, and each customer is assisted by only one salesperson. Salesperson to corporate customer. One salesperson can assist many corporate customers, and each corporate customer is assisted by only one salesperson. Employee to warehouse. One employee is assigned to one warehouse. Each warehouse has one employee assigned to it. Manufacturer to products. One manufacturer produces many products. Each product is produced by only one manufacturer. Return order. One return is associated with one order, and each order can have multiple returns. Quality check to return. One quality check is associated with one return, and each return undergoes one quality check. For damaged item and supplier, one damaged item is associated with one supplier. Each supplier provides multiple damaged items.
So next is salesperson to warehouse. One salesperson is assigned to one warehouse. Each warehouse has one salesperson assigned to it. Next, customer order. One customer can place many orders, and each order is placed by only one customer. Corporate customer to order. One corporate customer can place many orders. Each order is placed by only one corporate customer. Product and order list. One product can be included in many order lists. Each order list includes only one product. Product type and product. Each product or one product type can have many products. Each product belongs to only one product type. So, one manufacturer can supply products to multiple warehouses. Each warehouse receives supplies from only one manufacturer. Return and check quality check. One return can undergo many quality checks, and each quality check is associated with only one return.
So for the SQL, we first coded all of the entities and attributes that we got from making the ERD. And now, after running our code, we made a check constraint to ensure that the past status will only contain either passed or failed. And then we made a trigger that will update the order status in the order table whenever a return status is inserted in the returns table, the trigger function will update the order status from the values that was inserted from the return table. So for our check constraints, first we made a check constraint to ensure past status is either passed or failed in the quality check table. And the second check constraint that we made is that we made a check constraint to ensure return status is either approved or rejected in the returns table. And for the third check constraint, we made a constraint to ensure total price is non-negative in orders table. And for the fourth constraint, we made a constraint to ensure stock count is non-negative in the products table. And for the view tables, first, the product sales summary will summarize the total sales of each product. It calculates the total quantity sold and the total sales amount for each product by joining the product table with the order list table. Then for the order details view table, it retrieves the detailed information about orders, including the order ID, order date, total price, customer ID, customer name, customer number, product ID, product name, quantity ordered, and the order list price. For the customer order status, it will provide you with the summary of each customer status, including the total number of orders, the number of orders returned and approved, the number of orders returned and rejected, the total sales amount, the total returned and approved amount, total returned and rejected amount, as well as the total number of returns of approved and rejected.
So this is just additional navigation of the SQL. And that is all. Thank you for listening.